All right, so in this video, I'm going to continue our discussion of Module 2A, which provides a review and supplement to your textbook's Chapter 5, which covers short-term and working memory. So thus far, we have been talking about Badley and Hitch's 1974 working memory model. And in this particular video, I'm going to focus on their concept of the Visualspatial Sketchpad. And I'm going to talk about experimental evidence that seems to uniquely support this mechanism. So like I said, there are a number of experimental phenomena or examples of scientific demonstrations that seem to lend support to Badley and Hitch's notion that there is a mechanism called the Visualspatial Sketchpad that operates independently of the phonological loop and is processed via the central executive, or coordinated via the central executive. Okay, so let's talk about, I'm going to show you two different experimental demonstrations that seem to support the idea of the Visualspatial Sketchpad. Okay, and for at least this next demonstration, this is another example of one of the tasks that I gave you guys to complete in your lab assignment for this week. Okay. So in this particular study, Shepard and Metzler gave participants examples like this. So they were asked to judge whether two three-dimensional objects were the same or different. So is the picture on the right the same object as the picture on the left but rotated, or is it a totally different object? And for each of the objects, they were rotated in space to different degrees. Okay? And what the researchers found is that the degree of rotation affected the time it took participants to make judgments. So the more rotated the object was, the higher the reaction time, or the longer it took the participant to answer yes or no. Okay, right, so as you can see on this graph, we have reaction time on the y-axis in seconds and angular difference in units of degree on the x-axis, right? So like I said, you can see that as the angular difference gets higher or more significant, it takes participants longer in terms of seconds to answer the question, right? Is this the same object or a different object, right? So what does this suggest? Well, it suggests that the way that participants are answering this question is they are projecting the object onto their mental blackboard, so to speak, just like you did when you solved that problem, 43 times 6, right? You visualized the numbers as you manipulated them. In this case, participants are holding the object in mind and attempting to rotate it, okay? And by mentally rotating the object, that helps them answer the question, is it the same object or a different object, right? So obviously, the more rotated the second object is, the longer it's going to take them to answer the question, because the more mental rotation they themselves have to do in real time in order to arrive at the answer. Okay, so in my second example, this was the basic research design. So there were basically two different tasks that participants did. In one group of participants, they were asked to verbally rehearse each of the words that they saw, right? So they would see tree, for example, and they would have to say the word tree over and over and over again, and the next word would be presented, and so on. In the second condition, or the second group of participants, they were asked to form a visual image of the word. So in this case, they would sort of mentally picture a tree in their mind, right? And for some of each of these groups of participants, they either saw a blank presentation screen without anything on it, or they saw a random block pattern. And what they found is that when there was nothing being presented on the screen, or the screen was blank, memory, or the average percentage of words recalled at the end of the task, was pretty much the same, exactly the same, regardless of whether you verbally rehearsed the words or you mentally pictured the objects. Interestingly, however, in the case where participants were shown random block patterns, okay, we see that people in the verbal learning task were remembering way more words than people in the imaging task, right? So how do we explain that in a way that seems to support Badley and Hitch's model? Well, that random block pattern, right? Where is that information going in our working memory system when those random block patterns are presented? Well, it's a visual pattern, okay? Which means that information is going to be shuttled into your Visualspatial Sketchpad, right? So what happens for participants in the visual imagery condition is they have to use their Visualspatial Sketchpad to generate mental images of the object, but unfortunately, their Visualspatial Sketchpad is already overloaded with those random block patterns, right? And we know that in Badley and Hitch's model, both the phonological loop and the Visualspatial Sketchpad are limited capacity systems, right? So they can only hold so many items before they get overloaded, right? So if your Visualspatial Sketchpad is already busy processing those random block patterns, right? Then it's not going to have as much room or as much processing power left over to generate those mental images or to hold on to that information, okay? So your subsequent memory for those items is going to suffer. Okay, so these are just two examples of evidence that seems to support Badley and Hitch's concept or notion of the Visualspatial Sketchpad. Okay, so in my next video, I'm going to talk about experimental evidence that seems to support the third component, which is the central executive. And I'm also going to talk about new components that have been added to Badley and Hitch's initial model. Okay, so I'll see you in my next video.